ready to the countdown.
Tahniah! Secara langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Sebuah inisiatif e-didik Malaysia dan Kelab Guru Malaysia. Tumpukan perhatian anda. Secara langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Good evening and hi to all teachers, parents and students. Welcome to Pusat Tuisyen Academy YouTuber, a joint venture with e-didik Malaysia and Kelab Guru Malaysia dengan hashtag bermula percuma, selamanya percuma. So before we proceed, let's begin our session with the recitation of the Kitab Al-Fatihah for the Muslim and a moment of silence for the non-Muslim. Al-Fatihah. How's everyone today? So my prayer that everyone is in the best of health and ready to proceed with today's class. Before we start, let me introduce myself first. My name is Nun binti Muhammad Noh. You can call me Madam Nun. I am lecturer in College Matrikulasi Negeri Sembilan and I am your moderator for today's class. So the most important person today is our passionate and fantastic presenter, Madam Rosmaya. She is very experienced teacher from SMJK Yuhua, Kajang Selangor. So let us give a warm welcome to our presenter. Okay, so for the record, we are now live on Madam Rosmaya channel. So as a sign of support to Madam Rosmaya for the hard work in preparing to this lesson, please subscribe her channel. And as usual, the lesson will last approximately 1 hour. So the certificate link and the credit claim link will be given at the end of this session. Remember that you can only use e-didik email to claim the certificate. For the credit claim, you need to collect the 1 letter and 4-digit codes which will be announced separately during our class today. So be sure to follow the class up until the end to get the complete code for the credit claim. I would also like to remind all of you, if you wish to post comment in the chat box, please use appropriate language and use appropriate profile picture. I am pretty sure all students here are excellent students who will uphold a positive classroom environment. Please give your full cooperation in making this class a lively one. So stay focused, and if you have any question, please write on the chat box and Madam Rosmaya will try to provide you with the answers. Before I give Madam Rosmaya to present, I will announce the first digit code for the credit claim. Okay, so make sure that you write down somewhere. Yeah? So the first digit code is A15. A15. Okay, so without further ado, I welcome Madam Rosmaya to start her presentation. Okay, Madam Rosmaya.
Okay. Hi everyone. Bismillahirrahmanirrahim. Thank you to our moderator, Cikgu Non, Madam Non. And good evening everyone. I am Madam Rosmaya. I will guide you all through this live session on how to solve the static question. Okay. So the PDF questions, okay, for today has been given in the description below and also in the chat box right now. So before I begin, I would like to introduce the pre-U team in the Academy YouTuber. So for physics team, okay, I am Madam Rosmaya, the head of the physics team. Okay, and our members here, Madam Nong is one of the member for physics team, and we also have Teacher Su and Teacher Ayu. Okay, besides that, we also have maths team, okay, led by Teacher Im, and we have biology team led by Cikgu Faiza, and chemistry team led by Cikgu Shahnun. Perakaunan and Ekonomi PRAYU team led by Madam Fizi. And we also have other PRAYU subject, the STPM subject. Okay, like pengajian MURID, pengajian perniagaan and perakaunan. Okay, uh, so let's start our discussion now. Okay, on the topics solving problems on statics. Okay, so our learning objectives, okay, for today is by the end of this session, okay, you all will be able to identify and analyze static equilibrium situations. Okay, second, set up a free body diagram for an extended object in static equilibrium, and set up and solve static equilibrium conditions for objects in equilibrium in various physical situations. Okay. So before that, let's recall what we've learned before. Okay, so what is the condition for the object to be in equilibrium? Say, can you all remember or not the condition for the object to be in equilibrium? Okay, there are two conditions. Two conditions. Okay, an object is said to be in equilibrium if and only if there is no resultant force and no resultant torque. Okay, for Form 4, Form 5 level, you only learn the first condition. Okay, no resultant force. But for the PU level, okay, you've learned another condition, okay, which is torque, no resultant torque. So in the mathematical form, for the first condition, we use the summation here. Okay, so means that total of the force, okay, along x direction equals to 0, or total of forces along the y direction equals to 0. And for second condition, total of torque equals to 0, and torque is equals to the distance, force times distance, the perpendicular distance to the force. Okay, so the distance is measured from the fixed point we choose. Okay, so we know that there are 8 actually more than 8 actually, but for our discussion, okay, we just fix to this motion. The degrees of freedom is motion. So the motion, whether the object move to the right or left, okay, up or down, okay, forward or backward, or counterclockwise and clockwise. Okay, so this is a diagram for you to imagine. The direction here is actually right left, usually for the x direction. Okay, right left, and up down is the y direction, and forward and backward is the z direction. If you draw the Cartesian plane, you always label with x-axis, y-axis, and z-axis. So for counterclockwise or clockwise, so the object may rotate. Okay, if counterclockwise, usually we label it with a positive sign, and for clockwise, we label it with negative sign. So that when we total them up by putting this sign, okay, and we can equate them to 0. If the object obeys or satisfy the equilibrium position or condition. Okay, so for the up positive, down negative, we label the sign as negative. For the right positive, left negative. Okay, and for the forward positive and backward negative. Okay. Okay, so the direction for up, down, left, right, back, forward. So this one is the first condition for the object to be in equilibrium. Okay, and then for the second condition is this one. We use the torque. Total the torque equals to 0. Okay. So the solving procedure. Okay, so this is the general idea. Maybe can guide you with the how in the solution of this type of problems. Okay, on statics. So I divide into 5 steps. Okay, so step 1. Okay, draw free body diagram and label. Okay, for easier to solve, you can see from the label. Next step, you choose axis of rotation. This is a fixed point. So at a certain point, so this is a fixed point where least information is given. Okay. Then the third step, you extend the line of action for forces and then find the moment arms. And then the fourth step, then you start using the equation here. Sum of the total of torque equals to 0, and then sum of the forces along x or along y equals to 0. And lastly, we solve for the unknowns. Okay. When you form step 4 is actually you form equations. You form equations. Then for the step 5, you solve for the equations. The unknowns in the equations. Okay, now let's start with the question that I given already. Usually the PDF question I give 1 day earlier before our class for today, live class for today. And in the chat box also you can refer if those of you haven't got the question, okay, here, and you can get it from what I post in the chat box now. Okay, so let's read the question first. Okay, question 1. 3 blocks, we read the question first. So 3 blocks are attached to a uniform meter rule. Okay, this is a meter rule. So the mass of the meter rule is 150.0 gram, and the masses of the 2 blocks are shown in the figure. So here the 2 masses, one is 50.0 gram, another one here 75.0 gram. Okay, they are put at the mark here, 0 mark on the ruler, and here at the 30 mark, 30 centimeter mark on the ruler. Okay, then find the mass M3 of the third block that balance the system when it is attached at the right end of the meter rule. Here, M3. And also find the normal reaction force at the fulcrum when the system is balanced. Here we have also fulcrum here. So what is the force, normal reaction force at this point? Okay, so how to solve this question? Okay, by referring to the 5 steps just now. Okay, by referring to the 5 steps just now. Okay, what is the first step? Okay, what is the first step? So the first step, okay, go back here. Draw free body diagram. Okay, draw the free body diagram. And then label. Okay. So free body diagram means you draw without the all this like the ruler and the mass here. We just label it with arrow like this or the line. So the ruler here we draw line. Okay. Then the mass here, no need to draw the body. So we just label it with the mass given and convert it to the force. So convert to the force. So that's mean the gram, the mass here must times convert to kilogram. Okay, gram convert to kilogram, and then times the G value 9.81. Then we get in Newton. Force unit is in Newton. Okay, force unit is in Newton. Okay, next is the next one, that 75 gram convert to kilogram and then times 9.81 so that we can get 0.736 Newton. Okay, the force in the SI unit, Newton. And for reaction force here, or normal reaction force, okay, we name as R. We don't know. We are going to find later. So we just label it with R. And lastly, M3 we don't know. Okay, so we just label it with M3 and then times the 9.81 so that we get all equals in unit here. Newton, force. Unit for force is Newton. So unit for mass is gram. We convert to kilogram. So unit for force is Newton. So must be very careful with the unit. Okay. Next, don't forget, this is the one that student always forget. The ruler itself, the ruler itself has a mass 150.0 gram. So it was, we convert also to Newton, 150 times 10 to the power of negative 3 kilogram times 9.81. So the force is 1.472 Newton. So don't forget the force because of the ruler itself. Okay. Okay, now we have all together 1, 2, 3, 4, 5 forces act on the ruler. Okay, 5 forces act on the ruler. So label everything. Okay, next we go to step 2. Okay, so the free body diagram is this one. No body drawn here involved. So that it doesn't look messy for when we are going when we do labeling later. Okay, so for step 2, so what is step 2? Step 2, we choose axis of rotation or fixed point where the least information given. Okay, so we have two unknown here. This is we have M3 here, the unknown, and R here. So we put a fixed point. We choose a fixed point, either one. Which one? So it's up to you. So let's say we are going to find M3, right? We are going to find M3 first. So we choose R as a fixed point. If you choose the fixed point on the other three location of this F, so what happened? You will have two unknown, R and M3. So choose the one that the fixed point where it gives you the least information. So therefore we choose fixed point here. Okay, that is the second step. Okay, next third step. So what is the third step? Third step, you extend line of action for forces and find the moment arms. Okay, so the moment arms, we use this one first. We have five forces. So the first one 0.491. Okay, and to use the torque, so this is time distance. So force time distance is perpendicular to the to this force, and from an end it is measured from the fixed point. Okay, so now look at 30, 40. So 30, 40 centimeter. So total 70 centimeter. So convert to meter. So this is force time distance for this moment. So 0.491 times 70 centimeter perpendicular distance from the fixed point here. Okay, what else? Next is 0.736. So for 0.736, the perpendicular distance to a fixed point here is 40 cm. So 40 cm convert to meter. Okay. Then because SI unit. Okay. Then the third one, 1.472 Newton. Okay. So the perpendicular distance, here you need to calculate a little bit. So where is the meter, where is this 1.472 Newton at which position? So it must be at the center of the ruler, because the meter rule or the ruler is uniform. This is very important. Uniform. So therefore the force for this because of this mass meter rule, so it act in the middle, at the center of the meter rule, which is 50 centimeter here. Mark 50 centimeter. So therefore the distance from the fixed point here will be 20 centimeter. Because here to here is 50, and here to here also 50. Okay, so 50 left and 50 right. So minus the here 20 50 here minus the 20 30 here. So you get 20 centimeter. So convert to meter. Okay, next. And the R, no need to put also can, because we know that at the fixed point, the R times 0 will give you 0, because it's already at the fixed point. So the distance is 0. Remember that the distance here always measured from the fixed point. Okay, and lastly, don't forget the other side, we have 9.81 M3. 9.81 times M3. Okay, times, okay, the distance is 30 centimeter. Okay, so given here 30 centimeter from end here. Okay, so 30 centimeter. Convert to meter. Okay, now we have everything. Okay, we have everything, all 1, 2, 3, 4, 5. So at the fixed point, actually no need to write also can. Okay, now it's turn it times to go to the next step, step 4. Okay, fourth step. So what is the fourth step? So we are going to determine the sign to total up the top. This now is the top. Okay, so we are going to total up the top, and we need to put the sign. We need to put the sign. Okay, so all this 1, 2, 3, 4, 5. Okay, we are going to put the sign and then total them up and equate them to 0. That's the fourth step. Okay, so the first one is positive sign, because this 0.491, the force act on the ruler here will make the ruler or the meter rule rotate in a anti-clockwise direction. So for anti-clockwise direction, the sign is positive. Okay, anti-clockwise direction, the sign is positive. Okay, look at the direction of the force here. So the fixed point is where the ruler is not rotating. Okay, it's the center of the rotation. Okay, center of rotation. That is what the fixed point means. Okay, what about the 0.736? Also positive, because this is a fixed point. So this force, when it applied to the ruler, so what happened? It will make the ruler rotate in anti-clockwise or counter-clockwise motion. So that's why it's positive. Okay, just refer to the individual force. So you can forget about the other force. So by referring to this force, so it will make the ruler rotate in the counterclockwise motion. So that's why the sign is positive. So next is 1.472. So 1.472 also it will make the ruler move in the counterclockwise. So again it is positive. And lastly, okay, the R is no need, but you want to put also can. Okay, the last one, 9.81 is negative, because this force will make the ruler rotate in a clockwise. So therefore, the sign is negative. The sign is negative. Okay, now we equate all this to 0 because they are in equilibrium. So if they are in equilibrium, the total of this torque will be equals to 0. Okay, so now we solve for M3. Okay, so the fifth step is solve for the unknown. So do you realize that in this equation, the unknown is only M3. Okay, the unknown we can find easily because the equation here only give you one unknown. So you calculate M3, you get 0.317 kilogram. So this is already in Newton just now, right? Because we times 9.81, M3 in Newton. So the M3 here will give you straight away the mass. Be careful because the questions wants the mass, not the force. Okay, so the mass 0.317 kilogram. Okay, so for those who have done this question, maybe you get this question earlier before, so you can write there in the chat box that you get the same answer. So
Madam
congratulations.
Rosmaya,
Yes.
can I announce the second digit code? Yeah.
Okay.
So for get ready, student, for our second digit code, the code is number 7. Okay, number
Okay,
7.
7. Jot
All
that
right.
down.
Yes, of course. Okay, Madam Rosmaya, you can continue. Thank you.
Okay. So we've done question 1. So we go to question 2. Okay, we go to question 2. This one is M3 in 317 gram. Oh, we haven't finished. We got one more question. The question asks for the normal reaction force. We forgot about this one. This is another careless mistake made even by me, right? So we forgot one more question. So the question asks to find the normal reaction force R. This R. Okay, for normal reaction force. Okay, for normal reaction force, we use we go back to the third step. So the third step, we use another, the second one actually, fourth step. This one, total of fx equals to 0 or total of fy equals to 0. Okay, so we go to the fourth step. So for the fourth step, okay, we just take the fy. We choose fy because all these 1, 2, 3, 4, 5 forces is in the vertical, in the vertical direction. So 0.491 is negative because downward, 0.736 negative, 1.472 Newton negative, and R we don't know, so just simply put plus R. If we don't know, you just write plus R, because finally you will get whether it's positive or negative. It depends on the, because this is unknown on this the final answer, the direction for the R for at the final answer. And lastly, this one, 9.81 multiplied by the what you calculate just now is 0.317 kilogram. Okay, this one is minus because downward, and equate to 0. The total here should be equals to 0 so that the meter rule stays static. That's why the topic here static, no motion, okay, or equilibrium state. It is in an equilibrium state. So equate to 0, and do you realize that in the equation here form is only one unknown here, which is R. So you can solve for R, and for the fifth step, okay, we are going to solve for the unknown R. Okay, so the R is 5.8 Newton. Okay, 5.8 Newton. Okay, that's for question 1. Okay, now we go to question 2. Okay, question 2. So we read the question together. Okay, a man is holding a 20 kilogram dumbbell with his forearm. Okay, his forearm is positioned at angle 60 degrees with respect to his upper arm, and the forearm is supported by a contraction of the bicep muscles, or the diagram here. Okay, given, which causes a torque around the elbow. Okay, the elbow here. So assuming that the tension in the biceps acts along the vertical direction given by gravity, okay, what tension must the muscle exert to hold the forearm at the position shown, at the 60 degrees shown? So what is the force on the elbow joint? So assume that the forearm's weight is negligible. Okay, so we don't involve the forearm's weight. Okay, so we are going to determine two unknown, two variables here. The first one is tension in the biceps. Okay, so look at the muscle here. There's a bicep inside. Okay, next we are going to determine the force on the elbow joint. So here, the elbow here. So we are going to find the force act on the elbow here too. So two questions to be solved here. Okay, so what is the first step? Can you remember already the first step? Okay, you can join our live session here by writing there in the chat box if you can remember what is the first step. Okay, so the first step is we are going to draw the free body diagram. Free body diagram. So the free body diagram is without the body just now, the man's body here. Okay, so first step, go back here. Draw the free body diagram and label. So we go back. Okay, so we the forearm here. So we just draw a line. This is to represent the forearm. Okay, then the forces that act. And here is the dumbbell. So hold the hand hold the ball, the what you call this dumbbell. So the weight acting downward. Okay, then the force by the elbow. So we don't know yet the F elbow, which is on upward or downward, we don't know yet. So we just simply put, because later when you get the sign positive or negative, it will show you the direction of the F elbow. Okay, so we just simply put here, we don't know yet. tension, tension is upward direction by the bicep here. Okay, if you have X-ray eye, you can see the bicep here. So tension in the bicep here. So this is what we are going to determine. You can see through here the if you have X-ray eye, just imagine your X-ray eye. Okay, now step 2. Okay, only 3 forces act on the forearm here. Okay, next step. Okay, next step is choose the fixed point. Axis of rotation at point where least information is given. Okay, so we don't know T and we don't know F elbow. W we know, weight we know, 20 kilogram here, convert to weight later. Okay, so we choose either one, F elbow or T. So let's choose as F elbow, force by the elbow, because this one we are going to solve later. So we find the tension in the bicep. Follow the question asked for. This is the first one. Okay, so what is T? So this is the fixed point. Then step 3, extend line of action of forces and find moment's arm. So we are going to find the distance perpendicular to the force here. Moment. Moment about here, the fixed point. Okay. Force time distance from this fixed point. Okay, so the angle 60 degrees to help you to resolve the component of the T. Here is 60, here also 60. So it's alternate angle, so they are the same angle. Okay, then length is given here, 4.5 centimeter. And from here to here is 39 centimeter. Okay, so we resolve the component of weight. So here is W sine 60 degrees. So you use trigonometric ratio. Okay, so by PU level, you should know already. You should master already the trigonometric ratio. Soh cah tua. This one is sine, opposite per adjacent. Opposite per hypotenuse. So you get W sine 60 degrees. So for the tension, you get T sine 60 degrees. Okay, resolve the component of T. Okay, now for the third step. For T sine 60 degrees, the perpendicular distance is 4.5. So you multiply by 4.5 centimeter, convert to meter. Okay, next is W sine 60 degrees. So the perpendicular distance is 39 centimeter. Okay, so you convert to meter. Okay, so no more. This one is 0. The F elbow, no need to write because it's times 0. So we go to fourth step. So you equate to 0. So the total of torque just now, you equate to 0. Okay. So equate to 0. So that's mean you need to determine the sign, whether plus or minus. So T sine 60 degrees, for the fixed point here, the force, the T sine 60 degrees will make the forearm rotate in a counterclockwise. So therefore it's positive. And then the W sine 60 degrees will make the forearm rotate in clockwise direction. So therefore it's negative. Okay. By referring to the individual force only, don't refer to the other. So this one, W sine 60 degrees. So it will make the forearm with the fixed point here as a center of rotation. So it will move in a clockwise direction. So that's why it's negative. Okay, now you equate to 0. After you get the sign, positive or negative, then you equate to 0. And you can solve for T. So W is given 20 kilogram, convert to Newton. Okay, and then so if you use centimeter also can actually, because you can cancel out this meter. Okay, 10 to the power of negative 2. And then also sine 60 degrees, no need also, you can cancel out actually. So what give you for the solution, the fifth step, so you solve, so you get 4.5 T minus 39 W, okay, equals to 0. So that's why some of the some of the books, the answer given behind, they cut short the answer. So you are, maybe you keep wondering why not sign, not involved here, the sin 60, trigonometric, you use the trigonometric ratio just now. So this is the reason actually not in use. But you must master yourself the maths from 1 to form 5 first, to skip this step actually. So use straight away 4.5 T here, 4.5 T minus 39 W. Okay, so now we solve for T by substituting into here W 20 kilogram. So convert to Newton times 9.81. So you get T equals to 1,700 Newton. Okay, 1,700 Newton. Okay, so so now we finish this. So can we can take a break for the
Okay.
decline.
Alright. So, okay, everyone, let we watch the advertisement.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okay. Okay, Madam Rosmaya. Actually, I will announce the third digit code because of the time is 37 minutes. So, hi students. So our third digit code is number 2. Okay. Our third digit code is 2. Alright. So please write down somewhere. Okay, you can continue, Madam Rosmaya. Thank you.
Okay, so now we continue for the second sub question, right? What they are asked you to find is tension. Where is it? Force on the elbow joint. Okay, so for force on the elbow joint. Okay, so we go back to step 4. We go back to step 4. Okay, so the T we hold on here because we are going to use in the next step. Okay, so we put it here. T equals to 1,700 Newton. So for the fourth step, we use the force here. Fx, total of force along xx equals to 0. Okay, so we choose Fy lah, Fy. Okay, so F elbow plus T and plus minus W. Okay, F elbow upward, T upward positive, and W downward. Okay, because they are all in the vertical position. So straight away can use these three into substitute into the total of Fx equals to 0. And the fifth step, so we solve the solution. We solve for F elbow, which is equals to W minus T, and substitute the W minus the tension here. So you get force negative 1,504. So what does this means negative? So negative means the elbow is not in the upward direction. Okay, so the negative means in the downward direction. So it's not upward. Okay, F elbow downward. Okay, so now we go to the next question, question 3. Question 3. Okay. Okay, we read together the question. A uniform ladder is 5 meter long and weighs 400 Newton. So the ladder rests against a smooth vertical wall, and the angle between the ladder and the rough floor is 52 degrees. So find the reaction forces from the floor and from the wall on the ladder, and the coefficient of static friction mu of the ladder with the floor that prevents the ladder from slipping. Okay, so this is the ladder 5 meter long, and then the angle is 53 degrees. Okay, so the first step, okay, so we draw the free body diagram. Okay, so this is the ladder. We just draw a line here. Okay, then the weight of the ladder, because the ladder is uniform, so that means the weight of the ladder here act at the center, okay, downward, 400 Newton. Then because of it is the smooth wall, the vertical smooth wall, so therefore the end here is perpendicular to the wall. Okay, so the force, reaction force by the wall is perpendicular to the wall end. And then what else? Force from the floor. So the reaction by the floor. So reaction by the floor, we name as R. So in which direction? How to know it is in which direction? Reaction by the floor. It's not perpendicular. Why? Because it is a rough floor. Okay, the floor is not smooth. If the floor is smooth, so the R will act upward straight vertically from the floor. But because the floor is rough, so it will act at an angle. So which one to how to know it? Which one R1 or R2? So it's very easy. We use the equilibrium triangle. Equilibrium triangle. So the answer will be R1. So if you draw this complete this triangle, this is N in the left direction, okay, perpendicular to the wall, and then the W is downward. So what the third line should be to complete the triangle. Okay? So to complete the triangle, so the third line which represent the reaction by the floor is this way. Okay, so R1 is the correct direction for the reaction force by the floor. Okay, not R2 just now. Okay, so this is how to guess where the direction of R, right? Earlier before we solve to find this angle. Okay, so now this is R1 in this direction. Okay, next step is choose axis of rotation, fixed point. Okay, so the fixed point we choose at R1. Okay, R1 here. Okay, then the third step, okay, extend line of action for forces and find moment arms. So we find moments arm first. So by using this W and N. So the force time distance, where the force time distance must perpendicular to each other. Okay. Okay, so the angle here given 53 degrees. So that's mean here also 53 degrees, alternate angle, right? And then here also 53 degrees, 53 degrees. So use the similar triangle concept. Okay, you've learned in your secondary school. Okay, so next 5 meter. 5 meter also drawn here because we are not going to refer to this diagram any longer. So we just refer to the free body diagram. Okay, so you will solve the component of n. Component of n and sine 50 degrees. Okay, we take the vertical component. And the distance here, because the ladder is uniform, so the weight of the ladder must add 2.5 meter from the fixed point we chose just now. Here. Okay, and W, which also choose W cos 50 degrees. Okay, so now we can forget the diagram, the body diagram. We use this free body diagram instead for the fourth step. Okay, for the fourth step, so we use n sine n sine 50 degrees, which is 5 meter from the fixed point. So n sine 50 degrees is perpendicular to the 5 meter distance. Okay, next is W cos 50 degrees, which is 2.5 meter, perpendicular distance for W cos 50 degrees from the fixed point. And this is the fourth step. So the R1, no need because it's already in the fixed point, so the distance is 0. No need to put here. So next step 4 is to determine the sign, positive or negative, to complete this equation. Okay, so the fourth step. So the n sine 50 degrees will make the ladder rotate in a counterclockwise. Okay, counterclockwise, so it's positive. And then what about W cos 50 degrees will make the ladder rotate in a clockwise. This now not counterclockwise. This one is clockwise, so it's negative. And then we equate to 0. So we can solve for n. Okay. So you substitute the value of weight of the ladder 400. Okay, then you solve for n. So the answer is 150.7 Newton. Okay. Okay or not? Okay, can you all understand? Okay. If you got the same answer as me, you can write there in the chat box. Okay, so next, done for the first part. Find the reaction force from the wall, okay, from the wall N, to find the N. Okay, next we are going to find the reaction force R, from the floor. Okay, from the floor. So to find reaction force from the floor, so you can use the same method. There are two methods actually, more than one method. So instead of using this fixed point, you can can put this in another this point, fixed point, or you can use the FX or translational equilibrium. Okay, translational equilibrium. Okay, so if you are don't want to use the translational equilibrium, you can also use the triangle just now. Okay, N is this way, then W, okay, and the R here. So to get the R, you know N, you know W already, so you can use Pythagoras Theorem. So this is the fastest way. You can use the same method actually just now, but the fastest way is use the Pythagoras Theorem, because the diagram, the triangle here is already right angle triangle. So use Pythagoras Theorem, substitute the N value, and the weight here is 400 Newton. Okay, so you get R is 427.4 Newton. Okay, so that's R. And the direction of R, okay, if we calculate, it's not 53 degrees, it's not 53 degrees. So if you calculate here, the R here, look at here what we got. So tangent, we use trigonometric ratio. Okay, so tangent theta is equals to adjacent per hypotenuse. So the adjacent is weight, and the hypotenuse is opposite per adjacent. Okay, opposite per adjacent. So opposite is n, W, and the adjacent is n. So W per n. So substitute these two values and you get theta 69.3 degrees. So this R is not lies on the line or on the ladder. So it's 69.3 degrees, larger than this 53 degrees. Okay. Okay, so that is the answer. These are the answers. Okay, so now we go to the next question. Okay, so here it is drawn again at the diagram with the body just now, ladder. So R, we have Rx and Ry. So, got one more question. Got one more question. The question asks to find friction. So this is extra question. It combines topics in chapter. What chapter is that? Friction chapter. Okay, friction chapter. So we can use formula for friction. Friction equals to mu n. Mu n, or sometimes use mu r, right? So reaction force here. Normal force actually, N. So F, we use, because F is friction, okay, so we need to resolve the component of R. So we use Rx component. We know that the angle is 69.3 degrees, right? So we solve the component of R, so we use the Rx. This is friction. So the reaction force here comes from friction and normal. Ry is normal to the normal reaction from the floor, and Rx is the frictional force. Okay, because why Rx is equals to frictional force? So do you know why? Because the ladder is in equilibrium. The ladder is in equilibrium. So for static friction, Rx is equals to the friction. So Rx equals to the frictional force balance. So it's in equilibrium. So now Rx is R cos 69.3 degrees. So you use trigonometric ratio. Okay. So you get 427.4 cos 69.3 degrees equals to mu n. So the n is equals to the mg. Why this n equals to mg? Because the ladder is in equilibrium. It's static, right? So not moving. So they are balanced. So the n normal force upward equals to the downward, which is equals to the 400 weight of the ladder. Okay, so now we calculate for mu, so you get 0.378. 0.378. Okay, so that's for question 3. Okay, next we go to question 4. Question 4. Okay, so I can see there still nobody write your answer there. Is it too hard for you all? The question given. So this is the conceptual question. So related to this our surrounding, right? The situation in our surrounding. So now we go to question 4 about the door. The door. So we read first the question together. If you got any question, you can write there in the chat box. Okay. So a swinging door that weighs W equals to 400 Newton, okay, is supported by hinges A and B. So we have hinge A here and hinge B here. Okay, so that the door can swing about a vertical axis. Okay, so pass through the hinges. So the door has a width of B 1 meter, here 1 meter, and the door slab has a uniform mass density. So that's mean the weight will be distributed at the weight will be concentrate on the middle of the door here. That's why it's there uniform, uniform mass density. And you can ignore about this one, the what you call this the you assume that the door all is made of the wood. So uniform mass density. So actually for the door here, there's no window here. Window glass can see through the window, the door. Okay, the hinges are placed symmetrically at the door's edge in such a way that the door's weight is evenly distributed between them. So the hinges are separated by distance A equals to 2.0 meter here, 2 meter from the top hinge to the second hinge, so 2 meter. And then find the forces on the hinges when the door rests half open. So that's mean the door doesn't block by the what you call this the top here, the top side of the door frame here. We have a door frame here, right? So it's opening like this, rest half open. Okay, so now we just refer to the door only lah. So we draw free body diagram without the door frame here. Okay, so imagine this is a door. Okay, free body diagram, first step. Okay, free body diagram. Remember the 5 steps. Okay, so the weight of the door acts at this point, the center of the door. because the mass density is the best density of the door distributed uniformly. So that's why it acts in the middle here. Okay, next, the hinge here B. Okay, there are two components. Comes from the friction and from the normal reaction. So Bx and By, we draw like this. How you know By upward? Because if not because of the hinge, the door will sliding down, right? Because of the weight. So therefore the friction will be upward. So By upward. And then Bx surely on the right side lah, because normal by the door here, by the what you call this the hinge here. So Bx is normal to the wall or the frame of the door here. So same thing goes to A, but this time AX is on opposite direction because for the door to be equilibrium, so AX must be on the opposite of BX. And then the AY still upward because the friction AY is from the friction of the door here. So if there is no hinge here, what happens? So the door here will sliding down. So the friction will be upward opposite direction. So that's how you know the component of the B, BX, BY here, AX, AY here. Okay, so now we go to the next step. So the Bx and By will give you reaction Rb, okay, by the hinge, and Ay and Ax here will give to you the reaction by the hinge to the door frame just now as Ra. Okay, Rb this way, Ra this way. So if you draw the triangle, you manage to get the triangle equilibrium. Remember for the vector, triangle vector, for the what is we call this arrow must follow one after another, right? For the equilibrium state. So this is logic lah. Why RB supposed to be here in this direction? So W is downward, and lastly RA is this direction. So it makes a complete triangle where the direction of the arrow here is one follow after another to make a complete vector for triangle vector for equilibrium. So that's the reason why you choose this direction. Okay, so now after you know RA and B, so we go to step 2. Choose the axis of rotation. Fixed point, choose the fixed point. Okay, the fixed point, let's say we choose here. Okay, at the hinge A. Okay, so step 3. So we find the moment. Okay, moment arm. So given here 1 meter, here 2 meter. So for the W, okay, for the W, perpendicular distance is half of 1. So 0.5. So W is perpendicular distance from this point is 0.5. Okay, what else? So the BX here, okay, so the BX here perpendicular distance is 2 meter from the fixed point here, 2 meter. And for the BY, BY is 0 because it doesn't have the perpendicular distance. And then for AX, AX already in the fixed point, so 0. So and lastly AY also times 0 because it's on the fixed point. So what we have here only two moments here involved in the next part for the torque, total of torque equals to 0. So for fourth step, so we use this one, total of torque equals to 0. Okay, so the fourth step. So for the W, is negative sign because it will make the door rotate clockwise. Okay, clockwise. Clockwise, rotate clockwise because the W downward, right? So that's why negative. Okay, for the BX, so it will make the door rotate not counterclockwise. So it's positive, positive. And this one no need because 0 distance, 0 distance. So you can calculate for BX, solve for BX. So you get, substitute the 400 Newton, okay, for the door weight. And BX you get 100 Newton, okay, 100 Newton. Okay, done for BX. Next, we use the next condition, Fx or Fy. So let's choose fx. We can use both actually to find bx first, to find bx. So bx is equals to ax. W has no horizontal component. So ax equals to bx. Okay, so we substitute bx just now, calculated 100 Newton. So substitute into here. So you get ax also 100 Newton. They must be balanced because the door is equilibrium. If not balanced, so the door will the hinge won't support the door. Won't support the door. Okay. So ax we know 100 Newton. And for fy, okay, so ay and then plus by, okay, minus w, because ay and by vertical, upward, vertical, and w downward, vertical, so minus, and ay equals to by, ay equals to by. Okay, then you can substitute into here 2by or 2ay, it's up to you, but you get the same thing. By equals to W per 2, so W is 400 Newton per 2, so you get By 200 Newton. So Ay also will be 200 Newton. Because A and By and Ay is friction, so it's from the same surface, so both of them will be the same value, Ay and By. Okay, so now we put everything, label the value in the diagram here. Okay, the diagram here. Okay, then we solve for the we solve for the RA. So RA and RB. Okay, just now, right? RA and RB. So RA, use Pythagoras Theorem. So you get 223.6 Newton, and RB the same. Same reaction actually, because here is a make the triangle here W, so RB, RA, BX equals to AX, so AY equals to BY, right? So logically they are supposed to be the same, RA and RB. Okay, so to get the angle, we realize that also, okay, we calculate first, the angle, use trigonometric ratio, so you get 63.4 degrees. Okay. Okay. So you can also use here 1 meter and the 2 meter here, ratio of this one, to get the angle theta. Because the door is has equal mass density. And here also 2 hinge, equally spaced here, 2 meter from top and from bottom, in the middle here. Okay, so I think for the question 5 and 6, I'm going to do the video on that one because we don't have time, right, Madam Nun? Okay,
Yes, yes,
it's time already. So I
yes.
will make a video on that one. Okay, so I think we stop here. So wait for the video from me for the next 2 questions. Okay, Madam Nun, I give back to you.
Okay, Alhamdulillah, we have reached the end of today's session. Congratulations to those who can follow our session from the beginning till the end. So before we end our session for today, I will announce the fourth or the last digit code for the credit claim. So the digit code is number 4. Okay? Digit code is number 4, the last digit code. Okay. So all of you, please stop posting comment for a while, and if you haven't clicked the subscribe button, please do so. Make sure that it turns to gray color, okay? And activate the icon bell so that you will not miss the next class session. Then, if you find that the lesson was beneficial, click like and share to your friends on your social media. Spread and share the goodness. Okay, once complete, type done on the chat box before the certificate link is given as a token of thank you for your dedication in joining the free online class today. So I will share with you the the line, or Madam Rosmaya, can you please share the link for the EC jail? Okay, I will share you
Okay,
the link for the Academy
posted,
YouTuber.
post already. Posted.
Okay, thank you so much, Madam Rosmaya. All right. So all the links are already given in the chat box. So please take note that the link will end half an hour after this live. So make sure that to use the email, the email only to log in. So incorrect email use will not be entertained. If you haven't got one, please apply. The link to apply is also apply the email is also given in the chat box. So if you wish to get more information on the online classes, you can go to the academy www.academyyoutuber.com, and those who haven't joined EDD Junior Telegram, please do so. So once again, I would like to thanks all the students for joining our tuition class today. Remember that the more classes you join, the more credit you can claim. So feel free to share this free tuition class to your friends and teachers all over Malaysia. This is a collective effort from the teachers throughout Malaysia for all the students throughout the country. Thank you for being a YouTuber Academy supporter too. So I think that's it for now. See you in another session. Do not forget the hashtag bermula percuma selamanya percuma. And stay safe till we meet again next week at the same day and same time. Okay? So thank you. Assalamualaikum and bye.
Wow, banyaknya hadiah menarik menanti anda. Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma. Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang. Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.